So welcome. So the problem at hand is testing on application of derivatives and slopes. So let's see how we solve the problem. So let's sketch the two arcs. So we have then we have another one here. So this are the kind of problem we have. So let this small arc or the small head. So this is which has the function f of x given by 1 minus x squared. This other one, the equation is g of x given by 4 minus x minus 4 squared. So this is the board of the board. So this board is tangent to this small arc at this point, tangent to this other arc at this other point. So let's call the coordinates of x value here. Let's call it a alpha. So which means y value will be f of alpha. Let's call this point P1. And let's call this one P2. And let's x value here be beta. So this will be g of beta. So this is beta, and then this alpha. So then now, I tell her that any point on the curve of this small arc is defined by f of x 1 minus x squared. So which means P1, actually the coordinate is alpha, comma, f of alpha would be given by 1 minus alpha squared, because the x value is alpha. And then P2 will have beta, comma, 4 minus into beta minus 4 squared, or that the value that defines g of any x on this bigger arc. Now, slope of the board at P1 is equals to slope of the small arc or small hill. Then slope, so which simply means slope of the board at P1. Actually, the derivative of this one will be given by f prime at alpha is given by, so just say m, which is the slope of the board, so we call it m, then it will be the same as f prime at alpha. And when you differentiate this function, you get negative 2x, so it will be negative 2 alpha. Also, slope of the board at P2, the same as slope of the big arc or hill. So this means that gradient, we call this one M1, call this one M2. This will be given by G prime at beta. Differentiating this function, so expanding, will have 4 minus x squared minus 8x plus 16. So we'll have 4 minus x squared plus 8x minus 16. So when you differentiate, you get minus 2x and then plus 8. So it'll be minus 2 alpha plus 8. So minus 2 beta plus 8. So 8 minus 2 beta. But M1 equals to M2 since all defines the slope of the board. So that means that negative 2 alpha equals to 8 minus 2 beta. So which means alpha alone divided through by minus 2 will be given by beta minus 4. And call this one equation 1. And then, so equation of the board, actually board is like a tangent in this case. By definition is y minus y naught equals to m into x minus x naught. Now, if we pick for this x naught, using P1, remember P1 is alpha, comma 1 minus alpha squared, we'll have y minus, so y naught, so this case will be x naught is alpha, y naught will be 1 minus alpha squared, and then m will be the slope at P1 is minus 2 alpha at this point here. So we'll get y minus, so y naught is 1 minus alpha squared equals to m is minus 2 alpha into x minus x naught is alpha and call this one equation 2. But the equation of the board at P1 is the same as equation of the board at P2 because the same board. So at P2, X is given by beta and Y is the same as G of beta, which is 1 minus, which is 4 minus beta minus 4 squared. So then replacing this in 2, we get, so why this, why we put 4 minus beta minus 4 squared minus, so this one is 1 minus alpha squared equals to minus 2 alpha. The place where you have X we put by beta and then minus alpha. But from 1, we have alpha equals to beta. From 1, alpha equals to beta minus 4. So the same thing as saying beta equals to alpha plus 4. So using this, replacing these values into this equation, we'll have 4 minus, so beta minus 4 is the same as alpha, so it'll be alpha squared minus 1 minus alpha squared equals to minus 2 alpha into, where this beta will replace by alpha plus 4 and then minus alpha. So I just want to express everything in terms of alpha. So which means we'll have 4 minus alpha squared minus 1. So squaring this, will have actually, remember this is at this point, we have y minus alpha, or it's 1 minus alpha squared. So this is, the square is, this is, the square is here. At this point, we have y minus 1 minus alpha. So the square is on just alpha alone. So minus, so we'll have 4 minus alpha squared. Opening this will have minus 1, now plus alpha squared equals to minus 2 alpha. Now this and this cancels out, so we'll have 4. And here, alpha squared and alpha squared cancels out. So this and this cancels out. So we'll have 4 minus 1 equals to minus 8 alpha. So 4 minus 1 is 3. So 3 equals to minus 8 alpha. So which means alpha is minus 3 over 8. And the question was asking to find the slope of the board. So which means slope of the board is, I remember from where we started from, the slope using P1 was given by -2 alpha. So just -2 times the value of alpha. So it'd be -2 times -3/8. And this gives us 3/4 at the slope of the board. So that's how we solve that problem. Thank you. And actually, from the value of alpha, you can always get now beta from this equation. Beta is given by alpha plus 4. So it'll be alpha plus 4. So the same as alpha, which is -3/8 plus 4. When you work out -3/8 plus 4, then you get 29/8. So you can always get the coordinates of P1. So P1 was given by A, and then alpha, comma, 1 minus alpha squared. So the same as P1, alpha is -3/8, comma, so -3/8. Squared is 9/64, so 1 minus answer. So say 55/64. And then P2 is given by beta, and then 4 minus beta minus 4 squared. And you see the value of beta minus 4. Beta minus 4 was given by alpha. So this is the same thing as saying P2 beta, comma, 4 minus alpha squared. So this would be P2 is 29/8, comma, 4 minus the square of alpha squared is 9/64. So 4 minus 9/64. So this must be P2 as coordinates 29/8, and then 247/64. And actually you can try to see that if you say 247/64 minus 55/64 divided by 29/8. Now plus minus is 3/8. You get the slope m. So let's just confirm whether the answer will be same value I've gotten 3/4. So 2 minus 55/64. This will give us 3/29/8 plus 3/8. Then we get 4. So still agreeing. So we can get the exact coordinates of the points where the board meets the two arcs. And then also from that one, we calculate the gradient or the slope of the board. Thank you.